Alright, let's graph a tangent wave. One cycle of this tangent wave and state the period of the function. So let's recall some information about the tangent wave. First off, if we just have y equals tangent x, the pattern to graphing this, the period is pi for a tangent wave. Tangent goes through the origin. Half of the period to the right, pi halves, is an asymptote. And half of the period to the left, minus pi halves, is an asymptote. And then in between these asymptotes would be the period pi. Tangent goes in between, in the middle, it's at its baseline, which is the origin for the normal one. Halfway over, which would be pi fourths, it's normally up 1. And this left pi fourths down 1. This is an increasing function, tangent. With ours, first off, the period is different. So it's the normal period, pi, divided by the coefficient of x. It's 4 pi. Phase shift, there's no phase shift. That would be what makes the inside of the tangent 0. And x equals 0 does it. Vertical shift is the constant term, in this case minus 3. And the amplitude-ish information, it's not really an amplitude, but normally we, from the center in between the asymptotes, we'd go right half of the way to the asymptote and then up 1. This will go up 2. So, because there's no phase shift, this thing is still going to go through around the origin. It's not, it's a vertical shift. But from the origin point, we can go right half of the period, so I'm going to call this 2 pi, and left the other half of the period, and you'll find the asymptotes. All right. And in the middle, it's at this vertical shift. In this case, it's down 3. I'm going to call this negative 1, negative 2, negative 3, oops, negative 3, tick mark. Good. This is where this tangent is. Okay, now we've taken the phase shift into account. We've taken the vertical shift into account. We've taken the period into account. We have asymptotes. What's left is normally from this center point, halfway in between the asymptotes, we would go halfway to the right to the asymptote and up 1. This one will go halfway to the right in the asymptotes and up 2 from there. This point specifically, this is the value of pi. So this point would be pi, comma, negative 1. And then left and down to symmetric graph. This is one cycle of this trig function, tangent. I'm going to erase this stuff in there. I want to do another cycle. So 1, 2, 3, 4. This is the next asymptote. And then 1, 2, 3, 4. This is just all based on pattern of the first one. Recognize between these asymptotes, there's literally little squares, 1, 2, 3, 4, 5, 6, 7, 8, or every 2 of them, which is how I was doing it. 1, 2, 3, 4, gap. 1, 2, 3, 4, etc. These other asymptotes, and this is 2 pi. The period is 4 pi, so 2.4, this would be 6 pi. Another 4 pi, this would be 10 pi, etc. And this point halfway in between asymptotes and down 3. And then from there, halfway to the asymptote and up 2. Halfway to the asymptote and up 2. Left and down 2. I missed that point a little bit. Let's do this one a little better. Down 2. We have a bunch more. So the period is 4 pi. The asymptotes might be requested. Take an asymptote. You can take the negative 2 pi, you can take the 2 pi, you can take the 6 pi. I don't care. I usually go with the first positive one. So it's x equals, take the first asymptote you have, in this case 2 pi. How far is it to the next asymptote? It's the period. In this case, it's 4 pi. So then generalize that by 4k pi, where k is an integer. And then the domain would be the set of all x's such that x is not equal to these values, 2 pi plus 4 k pi, where k is an integer. These are common follow-up questions to the functions with asymptotes. Those are the tangent, the cotangent, the secant, and the cosecant. And in general, find your first asymptote and then add the distance to the next asymptote times k. And you've generalized your formula for the asymptotes. These asymptotes are always vertical asymptotes. That's why they're always x equals. All right. This is a translated tangent function.